Hello class, today I'm going to share with you in the topic of food quality and what is the measurement that have been used for measuring the food quality. If you are a nutritionist, you might thinking that the nutritional values of foods is the most important parameter, but microbiologists might thinking that food safety is the most concerns point. Chemists might expect that they should have the stable nutritional values or ingredients during the storage. For consumers, they have high expectation. They should have a safety food, the reasonable price food, and also concern about the safety at the same time. So food quality, if we talking about the definition, is conclude many aspects together. The good quality of food might have good sensory attributes, will have the safety in terms of microbial safety, supposed to have the stability during the storage, have the health benefit, and also with the reasonable price. If we're talking about the quality concept, it can be classified into two factors. The first one is intrinsic factor, or the factor that related directly to the food itself. For example, the taste, flavor, and texture of the food, shape, appearance, color, the health benefit, shelf life, the food safety, and the packaging that's suitable for that foods. This is intrinsic factor. Extrinsic factor is something that surround the packaging of food. For example, emotion of consumer. If you are in a bad mood, sometimes the good quality product can be bad quality if you are not in the mood that will enjoy the food anymore. Regulation. For example, I like to grill the beef, but when I grill at home, it's a little bit raw, but that one may not safe if you want to sell it in the restaurant. To follow the regulation, you may have to thinking about the internal temperature. Sometimes it might make the texture too tough, but you have to follow because it's the regulation and its impact to the food safety. Another thing is the availability, how convenient to find, how good is the service in the restaurant or in food service, and its price and brand. This one considered as the extrinsic factor. Why do we measure the food quality? The quality measurement doesn't mean that you measure only the finished product, but you have to concern or measure from the starting point or the raw materials, the in-process product, and also the finished product as well. On the screen is the food characters that related to the food quality. Chemical properties such as the nutrients or the moisture content in the food composition. Physical properties such as the size and shape and density. Sensory property is something that we can use our human sensing to detect, like sight, sound, smell, taste, touch. The last one is the microbiology properties, which is related to microorganism. So let's see the evaluation in the next slide. To measure the food quality, it can be divided into four different evaluation. The first one is the sensory evaluation. The second one is the instrumental evaluation, using equipment to measure quality. The third one is chemical evaluation. And last one is microbial evaluation. The sensory evaluation is the technique that we use human senses, including eye, ear, hand, mouth, and nose as the tools to evaluate the quality of food. On the screen is one example of the sensory evaluation. The descriptive analysis is the tool that we use our senses to access the food characters, which not be conducted by instrumental measurements, but we use our own sense as the tools to evaluate. The panelists in a number of 8 to 12 people, there will be attend the focus group. In the focus group, they will discuss what is the characters that's supposed to have in the food sample. Then they were trained for a couple months in order to make sure that every panelist have the same idea what is the characters that was showing in their own sample. After that, in the actual testing, they will get the tray that have samples on the tray. In each sample, they will have the 3-digit label to indicate what sample that they get, and they will have no idea what sample is, and they will have their senses to detect the intensity of food characters, and then mark the score in the paper that the moderator providing to them. After that, the score will be summed up to let the moderator have some idea what's the panelist thinking. Another example of sensory evaluation is the consumer acceptability test. The target customer will be asked for their degree of liking in the food sample. The target customer should not be trained like the previous panelists in the descriptive analysis because they was asked only how they like the sample. In their slide, they have 5 different degrees of ripeness of the grapes, and from the screen, when we harvest the grapes at 17% Brix or about 17% sugar, the grapes consumer like it not significantly different from the one that harvesting at 18%, 19%, and 20% sugar. From this study, we can conclude that the best time for harvesting the grapes is at 17% sugar because at that stage, the grapes itself still have a firm texture and easier for transport or have longer shelf life in the supermarket compared to the 20% sugar. At that stage, the fruit is riper and have softer texture, and at that stage it's quite difficult for transport. And this is the benefit of how consumer tasting affect to the research study. The second evaluation is the instrumental evaluation. This technique is to serve the disadvantage of sensory evaluation because even the sensory evaluation can evaluate the characters that is quite specific in food sample, but sometimes to dealing with people is quite difficult. For example, in the COVID stage like this, we cannot ask the panelists to join the sensory evaluation session, right? We have to have another things to measure the quality. What is the instrument that is more quite reliable and it's just a one-time investment. So it's quite important evaluation. And on the screen is the example of the instrumental evaluation that has been used a lot in food company. The first measurement that I'm going to sharing with you is the color measurement. The color is one of the appearance factor that consumer will pay attention in. It is the first impression when the consumer see our product for the first time. On the screen is the method that commonly used to measure the color of foods. The easiest and cheapest one is to use the color plate or the color chart. From the cherries example, we have the paper that have the hole at the middle to compare the color on the peel of cherries with the color on the standard paper, and it can divided the cherries into 5 graded. The measuring with the colorimeter, when we capture one spot on the apple, for example, we will get numbers, 3 numbers, what is the L star, A star, and B star. L star or lightness value, 100 is the most the lightest, and the 0 is the darkest. A value represent positive A is for red color, negative A is for green color. For the B value, if we have positive B, it represent yellow color, but if they are in the negative B, it is the blue color. These 3 numbers will be the specific characters of the spot that we measure and capture the photos. Tomato can be measured in many different methods. We can use the color chart, or we can use the colorimeter or the cylindrical shape probes that was shown on the slide. When we capture, it will providing us 3 numbers, which is the L star, A star, and B star, and we will know what is the location in the color sphere it is. And this one is the universal number. You can use it for communicate. For example, your customer will be in Europe and you measure in Thailand. When you get the number, the European will understand which color it is. For wine quality, color is not only the factor that will represent the good quality of wine, but the clear and this turbidity, the degree of turbidity, is the factor that will reflect to the quality of wine as well. In some food product, clearness will be the characters of food that represent the high quality. So the turbidity measurement will be the instrument that will giving the number that related or reflect the turbidity, degree of turbidity in that food. Turbidity is come from when we have the particle in food sample, and once the light source reflect the light into the sample particle, the scattering in many directions will providing turbidity to our food sample. Size and shape measurement is the very basic instrumental measurement, but very important at the same time. The size measurement can be measured by the dimension of foods, or we can measure the circumference or the thickness of food. Sometimes we use the balance to get the weight, or measuring and calculate the volumes of the food sample. On the screen is the fruit calipers or the fruit sizer. It is the instrument that designed for the specific foods, such as the calipers that designed for banana, or the sizer ring for apple. It's not necessary that we have to measure the weight of the sample directly. Sometimes we can use the estimation method. For example, in the US, the mango that sell in the store they are not weighting in kilograms, but they weighting by estimation. In this box, they have the specific size, and the numbers of mango that fit in the box will be the numbers of the size. In here, we have 18 mangoes. The number of the size is 18. But if we can fit only 8 mango in this box, we will call them mangoes number 8, which means that when we get the lower in terms of number, it means that our mango that we get is gonna be larger size. Texture measurements is the important characters for solid and semi-solid food. Solid and semi-solid foods have its own texture depending on the food composition. For example, the fresh mango, we have about 90% moisture content, and the dry mango, we have about like 10-15% moisture content. Do you think that they have the same texture? It's different, right? For the structure of food, when we have the raw egg and we have the hard-boiled egg, it have the same content of protein but different structure. The hard-boiled egg is the one that already denatured. The protein is already denatured, so the texture of them are different. The equipments that used for measuring the texture of foods try to mimic what happened in the mouth. This one we call the texture analyzer. The texture analyzer have many probes to measure depending on what is the thing that we want to mimicking. The first one is the bulk analysis. We're going to have a couple of blades. Then we connect together onto the probe, and then we cut them onto our sample with the shear force. Then we're going to get how much shear force we have to apply into our sample. Or when we want to make the compression test might represent when we use our tongue and then press our food sample in the mouth. And there are so many methods that they design for mimicking what happened in the mouth. Viscosity is another texture parameters, but it's not for solid food sample. This one is for the liquid or semi-liquid food sample. On the screen, I have 3 different viscometer to show you. The first one, my favorite, is Bostwick consistometer. For this, they will not give us the number of viscosity, but they will have the indirect number to represent how viscous of our sample is. The equipment act like an inclined surface, and tomato paste will be filled in the back chamber of this equipment. Once the blade is come up, the tomato paste will travel through the inclined surface, and then we can fix the time and measuring how far it can go, or we can fix the distance and we measuring time how long it's moved for that distance. And this one will represent how viscous the sample is. The second one is Brookfield viscometer, the probe that was shown in the slide. This probe will be fit into the container that filled with the liquid food sample. Once it's rotated, it's going to have the friction that occur. This friction will represent how viscous of our sample is. And lastly, the Oswald viscometer. We measure the time that our liquid passed from point A to point B, and then we compare with the density and viscosity of the water at room temperature, and then we will have the equation to calculate back how much the viscosity of our um, liquid of interest, and that is the example of the viscosity measurement. In this table, look at the peanut oil. When we measure at 25 degrees Celsius, we got one number for the absolute viscosity. But when we measure at 38 degrees Celsius, the number is changed. So when we measure the viscosity, we have to concern about the temperature at the measuring condition as well. Flavor measurement. When we talking about flavor, it will include both aroma and taste. Aroma is something that we can detect it, we can perceive in our receptor in the nose or the olfactory bulbs. So the compounds that will act like aroma compounds will be the one that have the volatile properties and also very small, so they can travel in the air from the source of aroma to our nose nicely. For the taste compound, the taste is the one that we can perceive in our tongue. The compound supposed to be soluble in our saliva and then can go through our receptor in the tongue. So this compound should be non-volatile and supposed to be able to solubilize in our saliva and can go through the receptor in the tongue. Gas chromatography is the equipment that we use for measuring the aroma compounds or the volatile compounds. For example, in strawberry aroma, they might contain about 40 compounds together to be a complex aroma, like single strawberry aroma. So all 40 compounds will be separate in the column within the gas chromatography by the different polarity will differentiate or separate them. And then we will be able to identify what is the compound by using the gas chromatography coupled with mass spectrometry. The second equipment can be used is eNOS. This one is the portable. We can use this one in the field or in food company that the quality control staff can carry them to many measuring point. So it's quite useful, but to be honest, the gas chromatography is the one that's more reliable. Okay, for the liquid chromatography, this is the one that we decide to measure the test compound. So the test compound will be solubilized in water, right? It's supposed to be in the liquid form, so we inject the liquid food sample into the machine, into the equipments, and then finally we can identify what is the compound that was composed of one food sample. In dry food product, moisture content is the important parameters to be measured. For example, in dry milk product, in dry milk powder, when we reabsorb the water into the food sample, the appearance is disrupted. It's all clumped together and the consumer don't like it. Not only for the appearance disruption, but the microorganism can grow better. So we have a problem in terms of microbial safety. This slide shows that in all food products, they have water even in the very dry food sample like tea leaves. They also contain percentage of moisture contents of 3 to 4%. There are many ways to measure moisture content in our food sample. The first one is oven drying method. This method is very basic, very simple and cheapest. We measure the wet weight of the foods and then bake in the oven a couple of times and then keep waiting until we get the dry weight that was quite constant. Then we can calculate the amount of water that was consist in our food product. The second one is the moisture analyzer technique. We putting our food sample into the tray and then they will record the wet weight and dry weight of the food samples, and it, it will calculate the moisture content for us automatically. Last one is the technique that we use it for very low moisture content food. It is the method of titration. This technique is suitable for the sample that have very low moisture content, like um, less than 1% or even at 1 ppm or part per million. At the end point of the reaction, the color of solution will change to brown color. Then we will calculate back how much moisture was included in our food sample. Temperature is one of the parameters that is directly correlated with food safety. In terms of processed food, the food supposed to expose to high temperature for a certain time. The only way to measure the quality of the heat treatment is to measure the temperature during the processing. In frozen food, we have to keep the temperature low, like for example, -20 for the whole storage time. The only way to keep measuring the quality of frozen storage is to measure the temperature during the storage. The cooking temperature for the meat, US FDA require the temperature at the center of meat to be at least 145 degrees Fahrenheit for at least 3 minutes. For the ground meat, the required temperature is 160 at the center of the ground meat, and for poultry as well, the central temperature is supposed to be 165 degrees Fahrenheit for at least 3 minutes. As you know from the previous lecture, using the cold temperature like -20 degrees Celsius for freezing the fruit and vegetables, it will not kill the microorganism or its spore, but it can just slow down the reaction or the growth rate of microorganism. For fruit and vegetables, the plant cell will be ruptured when we have the fluctuate temperature. The storage temperature fluctuated will affect to the size of ice crystal. It will enlarge and then will disrupt the cell structure. Once we thaw the sample, we will get very soft and mushy fruit and vegetables. This is an example of thermometer. We also have the thermometer that will punch into the food sample directly, or the one that will not even contact them. So we have the infrared thermometer to shoot at the point that we want to measure temperature, and it will reflect and then estimate the temperature of that spot. For chemical evaluation, there are many evaluation methods, but I will give you some example that has been used a lot in food industry. The first one is proximate analysis. This is the method that we use to estimate or to analyze how much protein, how much carbohydrate, fat, fibers, vitamin, and mineral was composed in our food sample of interest. The second one is the indirect method to measure the starch content in fruits. So let's move to the next slide. You doesn't need to remember about the technical term, but you have to know the principle of this analysis. This is the method that we use for measuring the composition of food, composition of the nutrients in that food product. We will know the moisture content from we baking in the oven until it's have a dry food sample. Then we can calculate how much water that is contained in our food sample. After that, we use the K-Down method in order to determine how much protein in our food sample. Then we can extract the dry food sample with the solvent, and then we'll analyze for the amounts of crude fats. Then we can put it in the furnace, and then the ash will represent the minerals and vitamins within the food. For the starch content measurement, this is the method that will indirect represent how much starch in the fruit sample. The cross section of this apple will dip onto the iodine solution. The more starch content it is, the more blue color will present onto the surface of the flesh of apple. The less blue color will represent that it have less starch content, or it can imply that it have more sugar content in that fruit. The last evaluation is the microbial evaluation. It is quite important because those small organisms will make us sick or even make us die. The first microbial evaluation that I will show you is the total plate count. To do the taste, the food sample will be diluted and then put onto the agars and then incubate for a couple days. All the viable or the living microorganisms in the sample can grow onto the agar. You can see that they have many white dots on the agar that we put our food sample on. The numbers of white dots will represent the sum of the living microorganisms that can be grown on our food sample. The second one is aflatoxin test. Aflatoxin is the toxin that was produced by Aspergillus flavus, or one of the mold that love to grow onto the dry food product, because it is the carcinogen and will cause cancer in humans for the long-term accumulation. That's why we have to have the aflatoxin test in order to make sure that the consumer will be safe when we eating our dry food sample. The dry food sample that will be tasted with this aflatoxin test, for example, the dry chili, dry spice, dry nuts. The last taste that I'm going to show you is the total coliform bacteria taste. The coliform bacteria are a large group of bacteria which commonly live in the digestive tracts of humans and animals. It shouldn't be found in food and drink. The presence of coliform bacteria in our food can indicate the possible contamination by animal waste or even human waste. We have to measure, we have to take this taste into our food sample, because the disease causing by this microorganism may be present whenever the coliform are found in the food product. On the screen is the method called most probable number or MPN. This is the method that we use to estimate the number of coliform bacteria that was present in our food product. The 10 milliliter of food sample will be add into 5 tubes, and then we add the chemicals inside. Once it change the color to the red color, we will count the number of red color tubes, and for the 10 milliliter of sample we got 5, right? Then we dilute 10 times. The numbers of red color tubes is only 3, so we record 3, and then we dilute another 10 times. The only one red color tubes are showing up, so we take a look at the table, and then we will get the number 531. So the number of coliform will hanging in between 40 and 300. This is the way that we use for estimation very nicely. So here is the last slide. Hope you can understand the thing that I try to explain. But if you have any problem, you can email me anytime. I will be happy to answer any problems, any question that will occur after you watching the video. Thank you.